Welcome back to the classroom. My name is Mr. Wong. Today in Year 10 Chemistry, we are going to look at synthesis reactions. Okay, so for the lesson intention for today's lesson is to define and describe a synthesis reaction. Your success criteria will be to describe features of a particular synthesis reaction and also, what are the requirements for a synthesis reaction to occur. Before we start, let's talk about a thing called exothermic and endothermic. Now, endo and exo represents two types of heat transfer. So thermic, our word that we have here, let's just change our color. Thermic represents heat, okay? When we refer to something as being endothermic, that is to enter, and when we refer to something as exo, that means exit. So when we say exothermic, we mean exiting heat. An example of that is fire. When fire is ignited, heat is being displaced into the surroundings. If we look at endothermic reactions, that's where heat is being absorbed. So if you can imagine to melt a snowman, heat from the surrounding is being absorbed by the snowman, and then as a consequence, the snowman is going from sort of a solid liquid water component, a solid component of water into liquid water. Okay. So let's explain the difference between exothermic and endothermic. Chemical reactions involve breaking and formation of chemical bonds. If we're looking at endothermic reactions, energy is absorbed by the chemicals to break the bonds. Okay? So if you imagine our sodium chloride, energy is being used to break the gap between the two bonds here to make it into two separate bonds. Now you can see here, this is an example of a decomposition reaction. So anything that decomposes or any form of decomposition reaction would be an example of an endothermic reaction because you need energy to break up the bond. A reaction is considered exothermic if energy is released through the formation of new chemical bonds. So this example we have here is a synthesis reaction. Okay, you can see when A bonds with B, they form one thing. Any excess energy in the bond is released as energy. So that kind of explains why when two things combine together, the surroundings get a lot warmer because energy is being released into the environment. So here we have things called an energy profile diagram. An energy profile diagram is used to compare the energies of a reactant and product after a chemical reaction has occurred. Okay, let's look at some features. On the left hand side we have the reactants in terms of the energy, and on the right hand side we have the energy of the products. Here we have an example of an endothermic reaction. In an endothermic reaction, the energy of the products is bigger than the energy of our reactants. The reason being is, remember, if it's an endothermic reaction, heat energy or any form of energy is absorbed to cause the reaction to occur. So you can see here we have sort of this hilltop shape. This is known as the activation energy. So it's almost like the energy barrier required for the reaction to occur. If your reaction doesn't go over this energy barrier, so the input energy you will not have a chemical reaction. If we look at exothermic reaction, we can see that the energy of the reactants is much higher than the energy of the products. Okay, so the overall activation energy would appear to be small in this case. Okay, so it needs to climb up this hill. If it has enough energy to overcome the activation energy, then a chemical reaction will occur. You can see that the products have a much lower energy than the reactants. So this energy excess, we can call it delta H, that is energy that is released. You can see with the endothermic reaction, the products have more energy than the reactants. So that's the energy that needs to be absorbed in order for this reaction to occur. You can think of activation energy as a roller coaster ride. The energy required for a particle to glide, break, and form a new bond with a different arrangement. If the roller coaster doesn't go to the very peak, you will not be able to go to the other side of the reaction. You will be stuck where the reactants originally are. And that's what activation energy represents. An energy barrier for a chemical reaction to occur. Okay? And this is basically speaking about what we talked about before. The minimum energy required for a successful collision is known as activation energy. With a synthesis reaction, it represents an exothermic reaction where energy is released after the two particles form into one. Okay, so let's get back to the concept of synthesis. In our previous lesson, we mentioned that a synthesis reaction occurs when two or more reactants combine to form one single product. Okay, the single product is a critical definition that we're using here. When multiple reactants form one product. It's exothermic because we're creating a new bond. All right. We can also see the general equation. We talked about it already. So creating new chemical bonds. An example we have, and we'll look at them, is the synthesis of nitrogen dioxide and the synthesis of sodium chloride, which is also known as table salt, the salt that you eat. So here you go, an example of the synthesis of nitrogen dioxide. Now, nitrogen dioxide has this red brownish color to it. Oxygen and nitrogen are both colorless gases. So the reaction we're getting here, when oxygen and nitrogen combine together, creating nitrogen dioxide, is this sort of brownish red gas. You can actually see this in terms of photochemical smog. So if you have the view of the Sydney Harbour Bridge or any location that is highly exposed to traffic, have a look at it during peak hour. Do you see this image here? This is photochemical smog. It's sort of a reddish brown color. This is the nitrogen dioxide that's formed by the reaction between oxygen and nitrogen in the air. The reason why this is created is because of the combustions that occur inside an internal combustion car. So this is the photochemical smog. One of the issues, one, it becomes a hazardous material, so it can be bad for people with asthma who breathe it in. It can also cause chemical pollution, as you can see. So those are some things we need to monitor when it comes to that. Another form of synthesis reaction that we have is the synthesis of sodium chloride. Now, sodium chloride is table salt. This is a really interesting one because table salt is made from sodium, one of the most reactive metals in the planet. If you expose any moisture to sodium, it will react really violently. And you have chlorine, which in its gas form is a highly toxic metal, and it was actually used in chemical warfare back in World War II. When you combine sodium and chlorine together, you get this spectacular yellow-green color of this reaction. After the reaction, you get an ionic compound in the form of sodium chloride. When we have such a reactive component and a toxic nonmetal, we somehow manage to create a really important spice that helps us govern the way we eat food. It's an incredible reaction, and you could say it's one of the big creations for humankind to use. Let's have a look at the following question. Which of the following is an example of a synthesis equation? If we have a look, it can't be A, because A shows a decomposition reaction. B is an example of a synthesis reaction because we have two or more chemicals forming into a smaller one product. We have this one here. This one is not a synthesis reaction, so there is some kind of combining going on here, but this is actually an example of what we call a single displacement reaction. And same idea with this one here, we have a single displacement reaction here. So B is the example of a synthesis reaction. Question 2, what is a synthesis reaction? Synthesis reaction is where we have two or more reactants to form one product. Describe this synthesis reaction that produces table salt. So table salt is formed from sodium added on with chlorine, and that forms sodium chloride. If you want to be fancy and show the chemical equation, sodium mixed with chlorine gas, we have a solid, we have a gas, and make sodium chloride, which is also a solid. You can see that chlorine, we have two of them, we only have one here, so we're going to put a coefficient of 2, which means we also need to put a coefficient of 2 in front of the sodium here. Last one, identify whether the following reactions are decomposition or combination. So combination refers to synthesis. So let's just tick off the ones that represent a combination reaction. Okay, that's a synthesis reaction. This is a synthesis reaction. And that's it. The rest are examples of decomposition. Okay. Okay, so that concludes the lesson in terms of what is a synthesis reaction and why do we know that a synthesis reaction is exothermic. If you enjoyed the video, give it a like. If not, that is that. Hopefully you found this video useful, and hopefully you found this whole tutorial about chemistry useful. Anyhow, have a lovely day, and I'll see you next time when a new video is uploaded.